Hello, everybody. Good evening. Welcome to the Virtual Night Sky. This is our version of the Virtual Night Sky for November the 2nd, 2022. Welcome to November. And lucky us, because we do this every other Wednesday, we have 3 meetings in November. So we will do tonight, 2 weeks from now, do another one. Thanksgiving will then be in between, and we have another one at the end of November. So we've got lots to talk about. Before I get started, let me sort of do some introductions. First of all, I'm Rick Alling, and I'm a manager of community outreach programs for the School of Earth and Space Exploration at Arizona State University. We're based on the Tempe campus, the main campus, but Arizona State University, you might know, has campuses now all over the Valley and in Los Angeles and in Washington, D.C. So we're kind of spread out and we're all over the place. We operate out of a building called ISTV 4. And I know many of you viewers, because we know from past, have come to visit us and seen what's going on at our facility. We're very, very pleased this semester to be restarting all of our K-12 field trip activities. So every given Tuesday and Thursday, hundreds of school-age kids, usually middle school, 5th graders and 6th graders, kind of trample into our building. And they get a wonderful tour of our facilities, and then they get a show in the Marston Theater. It won't be long before we're making some improvements in the Marston Theater, and we will be back open on a regular basis for the general public. Until then, we have some special events, and so we'll tell you about that at the end of the program tonight, some things that you can come do and visit with us. Suffice it to say that my role is mostly about the school and about visiting and about people coming to see us, but we started this Virtual Night Sky about 3 years ago, 2.5 years ago. And we've been doing it ever since, and we like it, and our audience likes it. So we're going to kind of keep doing this every other Wednesday for a while. I don't do it by myself, not at all. Kim Baptista is actually our webmaster, and she sets it up. She gets it going. She does all the technical work in the background and the notifications. And so you've probably seen her name before. Meg Hufford is my longtime colleague, and she helps me with the tours, or I help her with the tours. She's in charge of the K-12 field trip program. And we sort of have a lot of fun together on campus and sort of working with all the people that come through. So she's with us tonight as well. We have two students. Alex Blanche has been with us since the get-go, since the very beginning. He's kind of running a little bit of a cold tonight. Sorry, Alex, but he's joining us anyway. So we'll sort of make sure we're easy on him tonight. And Armandala kind of joined us about 3 or 4 months ago, and he's been giving us some insight into some coming events. And tonight he's going to give you a report on what to look for the lunar eclipse that's coming up next week. So what I'd like to do, another couple housekeeping things. This is a webinar format, so you can't chat with us. We don't do that part, but you can communicate with us. And so on the bottom of your screen is a little question and answer button. Push that button and it'll open up a dialogue. You just say what you want. We'll be reading it in the background. We'll answer questions as we go along, and we'll bring some questions forward to do on the air during the evening. But do that, please. Do dialogue with us. Ask questions if they come to you, because we do like to hear from you. We like to engage people in that particular way. That's good. We use closed captioning, and you're in charge of what that looks like on your screen. So use it if you like. You can turn it off if you feel like it's in the way. But we do that because we record these and later post them on our website. So if something strikes you tonight that you want to share with somebody else, give it a couple of days. It'll be on our website. You can send your friends a link to that. And that's free. So that's all the business part. The way the run of the show is going to go tonight is I feel like last week was a wonderful show. 2 weeks ago, sorry, was a wonderful show. We had a guest, Steve Simpkin. And it was more of the geological side of our business, right? The School of Earth and Space Exploration is also the earth sciences and geology. It also happened to coincide with a very important date every year that we remember earthquake safety. And so 2 weeks ago, we had a presentation with Steve Simpkin, Dr. Steve Simpkin, one of the professors in our school. And he's really up on that, not only earthquakes, but essentially the history of earthquakes in Arizona, which was surprising to find out there were some pretty amazing things that has happened to us in the past. That part of the program delightfully went way longer than we thought it would. So I kind of truncated. I didn't feel like I gave the other part of the program enough attention. So I'm going to kind of go back to that and finish there and then expand out. And I intended to show people some things about Saturn and observing Saturn. We're going to get to that tonight. So tonight is a little bit of a pickup of things we missed last week. And so I hope that's all right with everybody. I think it is. Along the way, I already mentioned there is a lunar eclipse coming up. We'll hear about that. There are also, we did finally get the announcements, finally get some timelines of 2 missions we've been watching very closely and some launch events that are coming up. We'll tell you about those and how those work. And then actually there are a lot of upcoming events, places where you can come see us. So we'll capture that tonight too. Anyway, let me just kind of get started. I like to use, as you probably already know, anybody that's kind of been here with us before, I like to use a little planetarium program to get us viewing the night sky. And tonight is really kind of just, as I said, we're going to kind of just go over some things we were talking about before. This particular program, what I use here is a program, I use it on my iPad, and it's called Sky Safari Pro. Sky Safari has a lot of different products. They sort of have different things for different things. They're in the classroom a lot. Sky Safari sort of uses a really kind of just easy to use technology so you can see how this works. Let me just kind of give everybody a quick little overview, but I'm zoomed out now to the full night sky. Everything that is not green, everything within that big huge circle is up in the sky tonight and I've got this set for 7:47, so kind of towards the very end of the program. I can correct that a little bit. Let me just go right up to 8 o'clock. You can see things moving just a little bit. Oops, 8:05. I'll go backwards a little bit. So 8 o'clock, as soon as we're done here, I think it's a little cloudy tonight, or at least it was in my neighborhood. I think we had some raindrops on my way home. So maybe tonight isn't the best viewing night, but I'm going to show you anyway some things going on. So if everything in this screen is above the horizon right now, what about us in Phoenix, Arizona? Can we see all this? Well, that's a problem. Even if it wasn't cloudy, we are in a big, huge metropolitan area, and the light pollution that happens, we call it light pollution. It's just errant light that just hovers over and captures all the moisture just right above our city and kind of creates this sort of translucent blanket right over us. It's not really that noticeable unless you really know your stars and you're out there really looking for some of the more dimmer stars. You'll find that they're just sort of hidden by this blanket, and that's kind of unfortunate for us, but it doesn't mean we can't still talk about these things. I can show you where they are. If you have a chance to get away from the city lights and out to a good dark sky place, then there's lots of things you can see that you can't see from here. So I'm actually sort of like pushing this around a little bit just so I can show you that as you see the horizon go by, now we're looking directly east. If I kind of go this way a little bit, we'd be looking at star systems that are in the north part of the sky and all the way around to the west and then down to the south. So this is really where the big action is happening right here, directly south of us, just right in that part of the sky. And I'm just going to kind of, I'm going to do a quick little screenshot here. I'm going to get the position just right so I can show you what I want to show you. I'm going to do a quick little screenshot, and then I can actually use my super pen here to write on the screen. Let me just change the color. And then we can go. So I'm going to circle some constellations, and you'll remember some of these names from last week, but this is Capricorn or Capricornus right here. And that is what we call a sea goat. It's a half goat, half fish. And right next to it, right, if you know your zodiac, is the constellation Aquarius. And you know that that's also water related. Aquarius is the water bearer. And we'll see, I'm going to show you a lot of depictions of Aquarius tonight. We're going to talk a lot about that particular constellation, but it's about water again. Right beneath those two is Pisces Austrinus, and that just means southern fish. And that's sort of also part of our watery part of the sky here. Over on this side of the screen, kind of going up this way and around, big, huge, sprawling constellation that's called Cetus. And Cetus is a sea monster, sometimes just called a whale, sometimes called a kraken, sometimes there's all kinds of different names for it, but it is a sea creature to be feared, to be sure. At least that was what the intention was. In a couple of weeks, either 2 weeks from now or a month from now, I'm going to do something. We kind of have done a program, and it's become an annual thing here where we talk about 6 other constellations just neighboring these up towards the northeast. And there's a whole story about Cassiopeia and Cephas and their daughter Andromeda and a sea monster and all that stuff. So you'll see Cephas again because it plays a major role in that particular part of the story. So we'll hear about Cetus again in a couple of weeks. Also, just up above here is Pisces, the fishes. All right, and it's kind of a fun constellation because there's one fish over in this side, and then usually in artwork there's this little ribbon thing that kind of goes around and sort of like goes back up like this, and then another fishy over on that side. And so that's kind of the Pisces is the dual fishes and the twin fishes. So there you go. It's part of the sky that indeed includes a lot of watery things. There's some interlopers up here too. This is a dolphin up in this particular area. Equus is actually a horse. Don't have to, that doesn't count. Down here, Grus is essentially a water bird. And if you go way down this way, not that we can see it from Phoenix, but way down below the horizon, you also have Argo Navis, which is the ship that Jason and the Argonauts, remember the voyage to go find the Golden Fleece and all of that kind of story happens. And that ship now broken up into 3 constellations, one for the sails, one for the stern, and one other, and the keel. And that actually is sort of down there. So this whole part of the sky, why is that? What's going on here where this whole part of the sky, it's in the south, it's this time of year, is all about water constellations. 3 constellations of the zodiac that sort of represent sort of that watery thing. As I mentioned 2 weeks ago, we kind of covered some of this, and I was suggesting that in the ancient days, 2 things are going on here. First of all, there is this idea that the land and the sky relate to each other. So your total cosmos is not only the land you live and work on, but what's going on overhead also sort of reflects what's going on the ground. And if you sort of understand that a lot of these constellations date all the way back to the Babylonians and even before in the Fertile Crescent area of Mesopotamia in the sort of the Middle East as we know it today, they had their cities. They were aggregating into big cities when these constellations were sort of being developed, and they had their stories and their mythologies, but they were also very agrarian. These were farming cultures, and they used the Tigris and the Euphrates River to create their big agricultural civilizations and all of that stuff. And we've already talked often enough on this show about how the stars and the patterns of stars during the year reflect those kinds of things. You would watch the stars, as you know, and you would they would tie into when you plant, when you grow things, when you harvest things. And it was known in those cultures that after the growing season, after everything was brought in, this is this time of year, you bring in all your crops, you get them stored for the winter, you turn to other occupations. And one of those occupations was fishing and going off to sea. So people that did this during the growing season would turn into sailors and people that sort of moved goods and things around. And the big ocean for them, the Great Sea, was the Indian Ocean, and it was in this direction. So from them, from their land, as they look at the night sky in the direction of the Great South Sea, the Indian Ocean, and then thus the links to India and the Indus River and what then became Pakistan and all of those places that they were trading with was down here. And so the stories about this particular part and those particular lands was important. There's another geographical reference here in some of the mythology about Aquarius. Aquarius was the water bearer, but also thought to be the source of the Nile. Right. So the Egyptians, of course, had this Nile River. They knew it ran from south to north. Right. It starts in the middle of Africa and then kind of comes up. But the actual source of the Nile River was not known to the people that lived on the Nile River. It was just essentially delivered. And so a lot of people think that Aquarius, the water bearer, was actually sort of the beginning of the Nile River, also to the south of all of these civilizations that were coming up with these mythologies and all that. So So that's really kind of where I wanted to just really make that finer point, is this relationship between people's sky, the dome over your head, and things that are going on in your life, in your occupation, and not only the seasonal nature of it, but geographical nature of how we use the sky to understand our place on Earth. And that was sort of kind of where I wanted to go with that. I also wanted to make one more comment about Capricorn. And to do that, I guess let me go to another sort of part of our thing here. I'm going to go back here and I'm going to bring up a star chart. And I'll explain these star charts to you in a little bit because I'm going to spend some time with this. First and foremost, I love these old star maps, and there is no one set. There's all kinds of different star maps, and this one happens to be from a publisher named Alexander Jameson, and this one happens to be a book published called The Celestial Atlas in 1822. So this is fairly late, and I'm going to show you some more charts. We're going to kind of go back in the old days and come forward here. But I wanted to do this chart to illustrate. So you see on the right hand of the screen is Capricornus. It's labeled, and that's the goat on one side, and that sort of like sea feature that goes out there. And I told the story 2 weeks ago. I won't go too much into it today, but this sort of goat was running away from trouble. It was actually a kraken. It was a typhoon, if you want, which is something that was riled up by the enemy, if you want, and running away from that, and then jumped into a river. And the part of his body that was under the river turned into a fish, and the part of the body that was out of the river remained a goat. And that's how we have this Capricorn. And the sea goat and that particular story plays in a lot of different mythologies, and it's become the thing. But I like the fact that you can kind of see here very directly, it's definitely the transition. It's this point in the year where we sort of stop thinking about agricultural things and we start thinking about seafaring things and the fishing things, and you can see the line of the ecliptic is the line that goes from the upper left down to the lower right. That is the path of the sun. The sun will sort of get in front of Capricorn in a little bit. This time of year, though, the sun sets way before this, and we can see it, and this is where it is, and that's really kind of a cool thing to think about. There is another reference to the goat at this time of year, though, and that is in the area of sacrifice. Remember, a goat was often, you sort of hear this in biblical stories and other stories and secular stories about animals being sacrificed. And this is that time of year where after the harvest, one would give thanks for all the food, right? So this is the time of year you bring that in, and then one would sacrifice to your god or the biblical god a goat, and it was sort of a symbol of a thank you and asking for the same cycle to repeat again in the fall. So the people knew that there's sort of this is a time of year to just take stock. Here's our crop. It came in. It was successful or it wasn't. You need to look forward to the next one. And this time of year is that. And that's really where the goat comes from. And then you see this really wonderful image of Aquarius. I want to show you a couple of other Aquariuses. So this one is about 350 years earlier. Look at the difference. So this is the particular artist here. I knew I'd forget his name, but the person that created this particular thing, his name is Erhard Ratdolt. Everybody's heard of him, right? Erhard Ratdolt, and he created this particular publication. It was called Poeticon Astronomicon, and it was essentially the poetry of the stars. But what he did us a great favor, is he borrowed these images or the descriptions of these constellations. So here's Aquarius again. He borrowed them from an ancient Greek Roman scientist and philosopher. His name was Hyginus, Gaius Hyginus. And Gaius Hyginus wrote about a description of the stars, wrote a description of constellations, but didn't do the artwork. And so he had something of a description. He said how many stars, where the stars were located on their body, what the description was. He had a fairly decent description of what was going on, but the artwork didn't carry forward. And that's what Ehrhard did in his book. He basically took that just really right after the printing press. This was done in 1492. So not long after we're just beginning printing, he created these woodcuts, and he did it off of the descriptions that came from Hyginus, which was 46 BC when he was sort of hanging around. He was a librarian in the Roman Empire. And he sort of did a lot of descriptions, and he is responsible for bringing forward information that was lost from Eratosthenes, which was 150 or 200 years before him. So I know this is a long, sort of long-winded thing, but there is this direct line of succession between the great Greek philosopher astronomers, and then people like Hyginus, and Ptolemy is another example, somebody that did this, that gave us some really tremendous descriptions that did sort of survive. And then Middle Ages people, just with the printing press, they took this information and did it. And this, apparently, I've read two different accounts. This particular book and these particular drawings were very, very successful. They went into many, many printings. So people liked this stuff. But importantly, these aren't the real locations of real stars, right? There isn't a trail of whatever that is, 30 stars coming down the spout, and as the water empties into that bucket. That doesn't happen. But it was a specific description from Hyginus from 1400 years before this guy came along, almost 1500 years, that was sort of doing it this way. So how did we get from here 350 years later to here? And that's really sort of part of the story. I've got some of our other characters here. Remember, we've been talking a lot about the Kraken, and there's Cetus right there, the sea monster. And you can see the ecliptic is in here again. That's that line sort of at the top of the screen, going sort of sloping down towards the right. That is the path of the sun. Now you see the exact location of real stars. You can see in here sometimes, it probably doesn't show up very good in the Zoom world, but there's stars that are named. There is an attempt here to make relative magnitudes known. So some stars are bigger and brighter than others, and you can see here. And then there's also a call out on this particular thing up towards the head in the neck of a very important star called Mira. Mira is a long period variable, maybe one of the first variable stars ever discovered. And it is known by this time and then called out. I love this particular time of these star charts and star chart making, because the science is starting to come through. You can see by looking at these things what they knew about the sky, what they didn't. Look at the lines and all that stuff. So you're looking at here two different coordinate systems, one that is equatorial, one sort of like following the equator, and the other one is ecliptical and following sort of the line of the sun. And that angle between those two things is essentially the tilt of the Earth, the 23 degrees, the tilt of the Earth. That's pretty good knowledge by this time. And people that were sort of in the printing industry took this on. They made these for sale. They were sort of sold to aristocratic people. Commoners couldn't buy these kinds of things. But there's this link between these ancient mythologies and these descriptions of these fanciful creatures and monsters and things like that that come forward as part of the background of the sky. But then they're laying on the real descriptions of the real stars in the real locations and taking time to do that. I think it's a really fascinating period. So you have Capricorn here, Aquarius. Let me just do Pisces, and then we'll sort of like get off of this and go on to the next part. Which one is that? Is it this guy right here? This will come on in just a second. Here it is. So here's the fishes. Remember I said there's the two fishes, and there's this little ribbon thing that kind of connects them together. You can see the water bucket in Aquarius is now kind of off the right side of the screen, and the ecliptic is moving through this, because the ecliptic moves through the whole 12 constellations of the zodiac. So we had in this particular, what we talked about in this watery part of the sky is the sea goat, Aquarius, the water bearer, and these fishes, along with the Kraken and others. And so anyway, I just suffice it to say, I love the charts. And what we're going to do is I have two books I wanted to sort of share with you, and I will do that, or I'll make sure that Kim puts it into the email that we send out afterwards to thank people from coming and all that stuff, because the references are nice. And if you're interested in this stuff, the books are thick. There are not just one publisher, there's probably 50. There's a good history of these publications and how they used art and how they did everything. One more image here, I'm just going to show you, because I found this today for the first time, and I wanted to show you this because it comes from a totally different culture. You see some of the same characters here. So let's see, you see the flying horse, the blue horse with the wings, that's Pegasus. You can see just above Pegasus, just above that stuff in the sort of the orangish looking kind of frock, that's Aquarius. And this was actually produced by an Indian artist, and it was also the middle of the early part of the 19th century. And it was during the British influence over India. So these are actually Western constellations, but they're costumed in Indian costumes. This one concentrates on the line of the zodiac. So you can see the main feature going now from the upper right down to the lower left is Sagittarius, Capricornus, Aquarius, Pisces, Aries the ram, and Taurus the bull. So 6 constellations in a row, all the way making a parade from right to left. That was the feature of this. These are the mythologies and the stories of the zodiac. This is something that has an astrological basis, and it was done for that purpose. But you can see they're using not only the zodiac, but the Western constellations on either side of that line of the zodiac. And that's all they cared about. There's much empty spaces in these atlases and these star charts and the lines that I was talking about. See, this is still that time period where we knew the coordinate systems, we knew how to design the sky, we knew how to mark where the star were, but they're all missing for this. You can see some gesture of line. In fact, the center of this screen would be what would be overhead in India at a very specific time of year. And so it's more like they're creating, if you want, this artist is creating a ceiling of the sky, an understanding of your sky from India looking up. And he wasn't that concerned about the positions of the stars. He was really just concerned about the characters and the positions of these guys for their purpose for mythology. I just think that's really a super cool thing to think about. And it crosses cultures. It's all over the place. And this is just a dabble. We could do many hours on the history of star charts and how they get to be, where they come from, how they've been influenced by real science as they develop, and how they sort of, I just like the part that we cling to these old images of fanciful creatures and mythologies and those kinds of things dating back, even though we know the science, we still kind of hang on to those things. And that's really why I find those fascinating. So I hope you do too. In recap, we're going to close out this chapter. So yes, there's a watery part of the sky, and it's directly to the south of us this time of year. Its relationship to the way people thought about the earth and the space of the earth and where they were, and the waters to the south seem to play here. The condition, the stories about the goat and all that stuff seem to play here. The stories about the origins of the River Nile seems to play in this as well. And then there's some science in there as well. So I kind of love that kind of stuff, as you probably know already. We're going to take a little break. And so we have a little poll, and I wanted to remind you, just go ahead and use that question and answer button if you want to ask questions, and come forward. And then when we sort of come back, I mean, I'll be here, but when we sort of get done with the question and poll part, we're going to talk a little bit. I'm going to have bring Armand to the screen, and he's going to tell you a little bit about the eclipse and what to look forward to and how to look at it. And then we're going to sort of like try to encourage you to get up really early in the morning to go check it out. So let's head off to polls and see where we are. Who's handling this part for us today? Alex, you're there. Hi, good.
Yes. So our first poll just got launched. How old is the oldest recorded star chart? You have 500 CE, 1490 CE, 1620 CE, and then more than 2,000 years old. And then while you're answering that, we don't actually have any questions, so be sure to send those in if you have them.
Audience,
but we do have kind of one from Peyton that is using their wonderful knowledge of Greek mythology to say that since horses were oftentimes associated with Poseidon, couldn't a horse also be in the water theme as well?
I'm gonna go with that. Sure, I think that happens.
Different perspective. So
there's two different horses in those scenes, and that's really kind of interesting because the constellations were designated at different times in history. So Pegasus seems to go back in ancient mythology, the flying white horse and all that stuff. And so see that a long time ago. But almost right next to him is another little constellation called Equus. And you probably know the genus species of, or the genus of a horse is Equus. And so Equus is essentially that, just a little horses. And I don't know everything. I don't really know where that came from. I'm sure it's in the books someplace to do that. But yeah, yep, I could go with that though. The actually pulling a chariot and that kind of stuff is probably part of that. It could be part of that. So that sounds good. Thanks for the question.
Yeah, and so then we'll end our poll. We'll share results. 56% of you had the right answer, more than 2,000 years old. So
Yeah.
really, really, really old.
So I think so we purposely put those sort of other dates in there because I specifically mentioned those for the charts we saw.
Mm-hmm.
But yes, we do have to sort of think that people were sort of sketching the sky and trying to understand the sky and trying to actually put some real, if I don't want to call it science because it's more observation, this sort of the real location of real stars. But it was a long time before that really became sort of natural or known or adopted, right? It was at some point more important just to say, okay, here's a star field, and here's the creatures and the constellations that are in this part of the sky, without really relating to the very specific real stars. That would come sort of over time and over later, and it's kind of cool to think about. All right, well, thank you. Yep, that's excellent. That's good.
Thank you. All right.
And I think we're on time. So I'm going to invite Armand to the screen. Everybody sort of remembers Armand Dalla. We usually count on him just to go give us some of the real sort of the Cliff Notes background on phenomenon. You know that Armand brought to us a program about the meteor shower last month. Sort of what to watch. And so Armand, you're going to get the reputation for getting people up in the middle of the night and making them go out and look for things. So do you want that reputation? Is that all right?
I don't mind having that reputation.
Okay.
Getting
He's
people
actually
to go
our,
out.
Rick, he's actually our moon tonight.
Oh, that's right. We meant to change his name tonight to our moon. Yeah, that's exactly right. So I messed that up. Sorry about that. Anyway, so
Right.
the eclipse coming up. Tell us about it. What's going on?
Yeah, there is a total lunar eclipse coming up next Tuesday, November 8th. Mark your calendars. But let's talk a little bit about eclipses and lunar eclipses in particular. So eclipses happen whenever one object comes in between another object and a light source. So a solar eclipse happens when the moon comes directly in between the sun and the earth. And a lunar eclipse happens when the earth comes directly in between the sun and the moon. The cool part about lunar eclipses is that during a lunar eclipse, if you're facing the moon, regardless of where you are on earth, you can see it. But during a total solar eclipse, since the moon is much smaller than the earth, it's only blocking out the sun's light totally in one small area or one swath as it moves across the sky. But if you're in a lunar eclipse, if you're facing the moon, you can see the eclipse wherever you are on Earth. And lunar eclipses only happen during a full moon when the moon is directly in between the Earth and the sun. But it doesn't happen every full moon because remember, the Earth is tilted an axis to the sun, and the moon's orbit is also a little bit tilted compared to the Earth and the sun. So that's why we don't see a total lunar eclipse every time we get a full moon. And these are a couple of pictures of what a total solar and lunar eclipse looks like. Remember, in a solar eclipse, the moon is blocking out the sun's light, and in a lunar eclipse, the Earth is blocking out the moon's light. But why does the moon turn sort of a reddish orange? Well, because the Earth is blocking out the light from the sun, the only sunlight that sort of gets through has to go through the atmosphere and come around and illuminate the moon. And so when it goes through our atmosphere to the thickest part of the atmosphere, the blue and green light sort of gets blocked out, and only the red and more orange light gets through. And that's the same reason why we see orange sunrises and sunsets, because the sunlight is going through the thickest part of our atmosphere, and the blue and green light is being blocked out. But how do you actually see the lunar eclipse? So like I said, mark your calendars for next Tuesday, November 8th. You can wake up really early or stay up if you're here in the US. The partial eclipse begins at around 4 a.m. Eastern, or 12 a.m. if you're here in Arizona. So if you're a night owl like me, just stay up, or you could wake up really early. And totality, when there's a total lunar eclipse, when the entire moon, or when the Earth is completely blocking out all the sunlight, that begins at 5:17 a.m. Eastern and 1:17 a.m. here in Arizona. But what can you do from now up till then? You can just go out and look at the moon every night. And remember how I said the total lunar eclipse can only occur when the moon is in the full moon state. So if you go out every night from now to the lunar eclipse, you can see the moon sort of change phases from, I believe it's in waxing gibbous right now, watch it change phases to a sort of full moon, and then stay up at night to see the full eclipse itself. And this total lunar eclipse is also the last total lunar eclipse until March 14th, 2025. So there'll still be partial eclipses here and there in between, but this is actually the last total lunar eclipse until March 2025. So I'd highly recommend you guys go out there.
That means we have to
get
get
up
out and see
early.
this one, right?
And yeah, it is really awesome. And remember, when you're seeing a total lunar eclipse, when the moon is sort of reddish orangish, you're actually looking at the combined light of all the sunrises and sunsets on Earth at the same time. And I think that's pretty cool.
I've never heard it described that way. Hey, can you go back to your last slide though? I'm going to question.
Oh yeah.
I'm going to question your times a little bit. So Eastern to Arizona is only 3 hours, not 4. So I'm afraid.
I think because daylight savings time ends or begins soon, that changes a bit.
I think so actually, it's so then we're going to end up 2 hours difference, not 4. So anyway, I'll tell you what we'll do for the audience, if you don't mind, because I meant to look at this beforehand and I forgot, we got busy and all that stuff. But we can probably, if you could just double check and just we'll just throw this slide on again at the end, and we'll just double check the times. Because actually one of the things I really like is you know, it's really beautiful once it's full and once it's totally eclipsed and once it has that really orangish color. But sort of seeing kind of the early part of the eclipse when you can actually start to see the shadow change and that kind of stuff. And so the timing kind of is important. But if you would just double check, I think that would be good.
Yes.
We can do that. But thank you so much to do that. And yeah, the combined light of every sunrise and sunset on Earth at that particular time. That's amazing. That's a good way to think about it. All right. Well, thank you, Armand. Hey, I wanted to I'm going to go back here for just a second, just to point out a couple of things, right? Important on this particular screen. This is the part of the sky we were just looking at. Remember that? We were like looking at Copernicus, Aquarius, Pisces, and all that stuff. But look what's happening. Oh, I don't need to flash that light over there. I'm going to put something down here. But look what's happening here. So Saturn right now is in the constellation of Copernicus, or Capricornus, sorry about that, over here. The moon is kind of right between Jupiter and Saturn, and so Jupiter is here. And if you've been noticing over the last several nights or last weeks or so, Jupiter has been really, really bright, and that's important because we're sort of close to Jupiter. It's prominent in the sky. It's in a part of the sky, as we've already talked about, that these are all very dim stars, except for this one right now, the one kind of in the lower center part of your screen. In part of Pisces Austrinus, that bright star is called Fomalhaut. We talked about that 2 weeks ago too. So anyway, you won't be able to visually see Neptune with the naked eye, but definitely go out and check check out this tableau. Those 4 objects is easy to find. And then remember this whole talk we've had about the constellations that are riding in the background behind, and use your observing skills. See if you can see some of those stars. I'll bet you can see some of the brightest stars in Capricornus. I think 1 or 2 of the stars in Cetus will start to appear for you, but check this out. So use Saturn, Jupiter, and the moon. We're looking directly south at 8 o'clock. And Pisces Austrinus, or the bright star, is Fomalhaut. So use that as sort of your guide, and that'll do it. We haven't done a thing called Planet Watch for a little bit. And so I just wanted to kind of just take you to this other program. For those of you that have sort of watched over the years and all the time, we sort of have this really cool program. It's called Digital Sky 2. It's produced by a company called Skyscan, and it happens to be the technology we use in our Marston Theater. When COVID started, and we started kind of doing these programs online, we worked with that supplier and the organization and all that stuff, and we were able to kind of get permission to bring that stuff home. I mean, it's all licensed stuff, but sort of they gave us permission to say, okay, you guys got some really cool stuff to do. And so basically I brought this computer home. We bought a new computer. It travels so we can use it on the road and other places. And it gives me a chance to sort of like show you a little bit what's happening in the sky. I always look at that. I always like the way to think about this is what do we get to see from Earth? And we just spent a lot of time talking about that. But what's actually going on in space at the same time? And that's actually kind of interesting. Here's your solar system. And I call this kind of feature, I call it Planet Watch. And what we do is we sort of size up the planets so you can actually see them. I just made Mercury, Venus, the Earth, and Mars 2,000 times bigger than it is, so we can sort of like see where they are. And then if you kind of look in the background over in this direction, I can go over here. There's Jupiter. Look at the Orion in the back behind the sort of main part of the solar system here. And right next to it over there is Saturn. So remember that image I was just showing you? I'm going to try to set it up. So the Earth is kind of in the center of the screen, right there. Oops, stop right there. And then let me roll this a little bit because it doesn't work the same way. And you remember I was just showing you a star chart where you can see Jupiter on one side, Saturn on the other side, the moon in the middle. That's not in this image because it's so close to the Earth. And then that bright star below those 2 objects is Fomalhaut. That actually is Pisces Austrinus. And so this is sort of a view of your solar system with the stars in the background. And that's kind of fun to see. I'm going to get a little bit closer here. And so look at the difference here. So there's the Earth in the middle part of the screen. Let me center it so that the Earth is actually center and not the others. And look at what we see. So if we're looking out in one direction, we're seeing Jupiter up in the sky, and it's brighter because it's a little bit bigger, and it's what's happening to my sort of controls here? Hang on a second. I just got my controls backwards. I'm not used to doing it this way. Hang on a second. So Jupiter is actually so bigger and brighter because it is, hang on one second. I'm going to just change something here. This is going to make me a lot happier. And I'm going to roll over again. There you go. Now I'm all set. So Earth is in the front here. I'm going to sort of flip around again so we can sort of see. Whoa. There we go. Goodness sakes, I'm having all kinds of fly trouble today. It's sort of like not like us. Sorry about that. I'm going to
Rick, we appreciate that you're driving the solar system.
I'm driving and talking
very well, my friend.
Anyway, so now here's the view I was kind of looking for. So you basically sort of have us looking at Jupiter. It's brighter in the sky because it's actually a bigger object and it's a lot closer. If I get a little bit farther away and start to see what that is, you know, it's actually almost, it's more the distance to Saturn is more than twice the distance from the Earth to Jupiter right now. It's farther in its orbit, and and we are closer to Jupiter because we're on that side of it, and that's really why it looks like it does. The other thing I wanted to show you just now is if you can kind of get into, I'm going to get into the Earth and give you our view of Saturn, and I'm going to get really close to Saturn here in a minute, but I want you to notice how the rings are set up. So Saturn, like the Earth, is tilted, we're tilted 23.5 degrees. Saturn is also tilted so that its equator and then therefore its rings are not exactly on the plane of the solar system. So it's basically journeying through space, and we're journeying through space, but it's going in such a way that it's exposing its rings to us. So a good telescope view of Saturn right now kind of shows you the ball in the middle, just like what you're seeing here. And then you get the rings. You can see that they sort of lay, kind of they're exposing themselves to it. I don't know a better way to say it. You can see they come around from behind the planet and then go across the planet. It doesn't have to be that way. And so I was looking back in time, and if I go back to, I think it was, let's see, 2009. Let me just kind of go here. This is going to be a little abrupt. And let me find Saturn again. And when we find Saturn in its orbit this time, you can sort of see that now when we're looking at it, this was about 12 years ago, the rings, as we sort of saw them sort of laid out so that they're in a good position for us to see, are almost edge on. And so there's a period of time from about 2005 to about 2009 that Saturn was kind of uninteresting. It was a ball in space, and you could sort of see, maybe if you had a really good telescope, you could see the little wisp of rings out there, but way better now. So let me just go back to now, so you sort of see, just to sort of like set that up. Going back, Saturn is now over this way to us, and you can sort of see the difference there. Right now it's kind of laid out and easy to do. So I think that's really good. I'm going to kind of just take us right to Saturn, because I wanted to show you something, and then we'll fly past the Earth and out to the object, sort of see. Speaking of star charts and ancient astronomers, it was really wonderful to see in the star charts. There's a family called Cassini, and that is actually, there was 4 generations of Cassini astronomers. They were originally from Italy, and then they ended up in France, and they were sort of prominent French astronomers through the time. And one of the Cassinis also made star charts. But the reason to bring that up is these little divisions in the rings of Saturn. You see there's sort of the rings, and then there's those little breaks. There's one really, really severe one, like a little empty space. And then there's another little tiny one towards the outside. I've never done this for this audience before, so I'm going to try something we haven't seen before. But out there is a little moon. I'm going to sort of just give you the orbits of all the moons to begin with, so you can see what happens to Saturn. And hang on one second. Boom, 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 boom. Oh, I know what the problem is. Hang on for a second. Just a second. I have to take us back down again. Saturn was bigger than the orbits of all of its moons. So Saturn actually has numerous moons, and you can see the ones in the middle there actually are along the same alignment as the rings. See right that? But then there are other moons that seem to be more in alignment with the plane of the galaxy. And so that happens to us in the gas giants. Some of those moons look like they seriously belong to the planet itself. And they're equatorial. In this particular case, it's sort of hard to see the distinction between all of these Saturn moons and the rings themselves. But remember, I was talking about that little division there. I would love to do this. I'm going to center on a moon of Saturn called Pan. Pan, you should sort of relate to our other part of this discussion, because that is the guy that had goat horns and goat legs, and but was a man's body, and he played the flute. As I get a little bit closer and closer and closer and closer, you'll see sort of something come into view that is really, really kind of cool. As you see, we're getting into the rings. We're heading for one of those divisions. I'm going to turn the orbits off. And we're going to find this little tiny moon. It looks like a walnut. See that right there? That's a moon called Pan, and it sits right in that little division, right in that open space. And so the science of the thing will tell us that when the rings were in formation, there was some larger debris, some things like this particular moon, and it essentially swept out or cleaned out the whole thing. Now notice that bulge in the middle. You see that? This kind of looks like a little walnut, doesn't it? That bulge in the middle sort of represents the thickness of the rings themselves. And so you can imagine this little thing is kind of like a vacuum cleaner. As it moves through space, all of the little sort of ice crystals and dust and debris that is causing the rings to happen is starting to collect on the body of the moon. Now, this is ancient. This happened billions of years ago. All of this is sort of like petrified ice at this point. But the moon and the shape of the moon is a result of it happening to be in formation in the same area of the rings, and then over time kind of cleared out that particular ring completely and drew all that material into itself. And so we can actually learn from Pan, if you want, something about the formation of the rings, something about the formation of moons around Saturn, and all of that. And so back to kind of just the observing Saturn, you can actually see these rings with a good pair of binoculars. It doesn't take a major gigantic telescope. A hobby telescope, one of the smaller ones, the kind that people would have around the house, that will actually show these rings as well. You can see in this particular view, there's also a shadow of the ring going across Saturn itself. And so a bigger or good telescope will show you that. A 6-inch to 8-inch telescope will actually, you can see the division in the rings. You can start to see some variation of that. And all of that is really sort of observable right now, but I'm kind of just giving you this warning. It would be a good time of year to see this because we are moving around in our orbit. The Saturn is going to move more and more and more towards the west, and eventually it will be lost in the sun's glare. That will take a couple of months, but every day it's getting just a little bit further away. And so we want to probably take advantage of seeing it now rather than another time. So anyway, that's kind of where I wanted to leave that part. I'm going to go back to real life, and we've got some other things to talk to you about today. So I think the next thing coming up is going to talk about some events coming up. And do we have any more questions? I'll throw it out for that.
Actually, we're gonna have Armand come on and just clarify the times.
Oh, I see. I sorry. Good. Yep.
My apologies to everyone. I got the times mixed up, but the partial eclipse begins at 2:10 a.m. If you're here in Arizona on Tuesday, November 8th, and totality begins at around 3:15 a.m. Again, there's only a 2-hour difference between us and the East Coast after daylight savings time.
Oh, that darn daylight savings time
Yeah.
thing. Darn it. We're gonna have to get rid of that. I think actually we're sort of planning on getting rid of that at some point. Okay, that's better. So then Armand and I are going to recommend you guys head out just a little bit after 2 and hang out until about 2:20, 2:25, just to sort of see the sort of the shadow bite taken out, and then either hang out until 3:17 or go back out at 3:17 and kind of take a look at that really bloody, really beautiful orange moon, and then you can watch the opposite happen out the other way. It's one day a year. And how long did you say again how long it is before we get to another eclipse like this? It's a while, right?
It's the next total eclipse will be in the next total lunar eclipse will be in March 2025. So a couple years until the next total one.
Okay, well, this is it. This is the one we got to see. I'll be out there. I'll do it. Okay, in fact, I think we have a poll question like that. Are we going to ask the audience if they're going to go look at the moon? Okay, let's do that. Let's just see how we did. Did we entice everybody to sort of like put this on their calendar? Are you going to do it? You get to vote.
A lot of these people probably have healthier sleep schedules than me. They will get up early that morning to see it. I know I won't. I'm gonna be
I know, Alex,
fast
we-
asleep.
Come on, Alex.
we've asked you about this before, and you seem to be like really reluctant to like
No,
do something.
see, I'm someone who astronomical events like late at night. Like if it's 2 a.m., 3 a.m., I'll stay up. But if it's 4 and 5, I can't stay up that late, and I'm surely not gonna wake up that early. So unless it's like something like really I'm nothing against lunar eclipses, but unless it's something really spectacular, like a total solar eclipse or maybe the aurora borealis, I'm not gonna get up that early.
I get it. That's all right with me. That's all right.
Well, that's
So did
me.
I'm sorry. I closed that poll on my screen. Did it get answered? Or is anybody?
It's
doing it?
there's still some results coming through. It looks like a lot of people have answered it. We got about 80%. So I think we'll end it. I'm very surprised. Over 80% of people said that they are going to watch it.
They're
gonna
going to
get
do
up and watch it.
Yeah.
Yeah.
So Armand, you've convinced them.
And so this is good. You sort of won. And so everybody,
It's
when you're
our
out
moon,
there,
Alex. It's our
our
moon.
moon. When
Our
everybody's out
moon.
there
I'm
looking at
sorry.
when everybody's out there looking at
Sorry.
this eclipse, think of our moon, and he got you out.
Mhm.
He got you out there. Sort of like see that works. Excellent. Well,
Take
that is
our
really
moon's
good.
advice,
That's
take a
happening.
nap.
So, all right, good. And thanks for the clarification, Armand. I just thought
Yeah.
we better do that. So that's good.
Yeah.
Thanks for looking. Anyway, let's see. I guess we got some announcements. The next thing we wanted to do is just say, hey, there's some things coming up, and so I'm going to turn it over. We have an order to things, right? Kim and Meg and everybody's going to do announcements, right?
Yeah, it's just one big party tonight. So
It is.
yeah,
going on?
so first thing I'm going to share is a launch that we are anxiously awaiting for. And that's the Artemis 1. It is scheduled to roll back from the vehicle assembly building this coming Friday at 12:01 Eastern Standard Time. That's AM. So we'll see if I think it's all on schedule, ready to go. And the reason we're watching that is because LunaMap, our CubeSat that was built at ASU, is one of the secondary payloads on catching a ride on the Artemis 1. So we're anxiously awaiting.
Excellent. And so now, Kim, you've told us before this is going to launch, and it didn't happen. So
I know, but sometimes there's a leak, or sometimes there's a thing called a hurricane.
right, to remind the audience, so it went out and then had 2 delays because of this hydrogen leak, which apparently
Yeah, which is when I was there, and you guys thought you were
that's
gonna
right. You were there,
fail to me there.
and then you came home, and then they sort
Oh.
of had this idea, but then that gigantic Hurricane Ian, the one that hit Fort Myers, came
Yep.
through. And they had to protect the rocket, roll it back into its little
Yep.
hole, and it's fine. But so this is going back out again. And so remind me so when do you expect it to actually go into the air, if it's going to
The launch is currently scheduled for November 14th at 12:07 a.m. Eastern Standard Time. So that's early Monday morning. But that's really Sunday night for us.
Yeah, okay.
I think, did we land on, we're 10:07
I think
p.m.
10:07. Yeah.
for us? So doing all that math with
If we get
daylight
that
saving time. So it'll be Sunday evening for us. It'll be early Monday morning for the folks in Florida. So stay
Okay,
tuned for that.
And for the audience, just know that everybody at ASU, especially in our school, we're just going to be cheering this on. I mean, this is a great project for us. Artemis is an amazing exploration anyway. It's eventually going to get men back to the moon, but our little piece of this is a bit unusual, and we've been watching it. We've been watching the team build it. We watched it go to Florida. We know it's on board, and finally we get to see it deployed into space, and that'll be really exciting.
So here's fingers crossed, and I'll let you know if I'm actually going to be in Florida. I'm still waiting I'm waiting till the last minute to decide if I'm going. So.
All right, who else? Somebody else has on the line.
Alex,
I'm next.
Next big news.
Yes. So the Psyche mission, for those of you who aren't familiar with it, Psyche is a ASU mission that is going to send a satellite to a large metal asteroid to study asteroids and also planetary formations, because we think it used to be a planetary core. But the thing is, Psyche was originally slated to launch this year in August. There were some technical problems that delayed that, and there was a little bit of kind of up in the air. Are we going to continue the mission? Are we still going to launch it? And NASA announced that it will be continued. It'll be launching next year around October 10th. That's when the launch window kind of opens. So Psyche will continue that spacecraft. Our former director, Dr. Lindy Elkin Stanton, and her team are still going to be a part of that mission, and we're still very excited for it. But it'll be coming next year, so keep an eye out for that. We're all very excited for the
Definitely
mission,
keep
and
it
we're very
posted.
glad to hear that it's going to keep going.
That is going to be quite a celebration to get that one in the air too. So we're really glad.
That'll be a big one.
I'm glad they continued it, and it's really good news for us this week. So excellent.
Yes.
All right, Meg, what's going on in your
Okay,
world?
well, go Artemis, go Psyche. Rick, excellent Planet Watch tonight. Good evening, everyone. I'm here to tell you about an event that's happening this Friday night, and it is Earth and Space Open House. This event has tradition more than 20 years, and it is managed by our graduate students, by our CC graduate students. We're inviting all of our friends from Virtual Night Sky. Please pass the word. The event runs from 6 to 9. Doors will open at 6 p.m. at ISTB 4. The first Marston 3D astronomy presentation will be at 6:30. Regents Professor Roger Windhorst is our keynote speaker, as the theme is the James Webb Space Telescope. We're very excited for any and all new information, and we will get that from Professor Windhorst at 7 o'clock, from 7 to 7:30. Then from 7:30 to about 7:45, some of Professor Windhorst's team will be with us for question and answer. The next Marston program will begin at 8 p.m. But the doors are open until 9 p.m. and there are many, many exhibitors to share the research of CC. There'll be some great demonstrations, and we do invite you to come out. So from 6 to 9 this Friday, November 4th, please join us for our fall Earth and Space Open House. Come on down, everybody. And one more thing, we're always looking up. We encourage you to continue to look up whenever you're nice enough to leave a comment. I want to share with you that on my way home tonight, when I got home, I was blessed with this. Were you looking up tonight, everybody? Did you see the rainbow? I sure hope
missed
so.
it. I was looking the other
Sure
way.
hope so. It's always good to look up, and that's a good reason. So thanks for that, and hope to see you this Friday at Open House, Earth and Space Open House. Thanks, everybody.
Wait, we have one more thing to share with you.
Goodness
And
sakes.
that is homecoming is Saturday, November 19th.
Woohoo.
We don't know the time yet. We probably won't know until that week, but just so if you're in Tempe, come by and see us. We'll be, I'm not sure where our location is yet this year, but we're gonna be at homecoming. So come by and say hello, and we'll let you know when we have the time. That's all I have for events.
Perfect.
Busy.
All right.
We're busy.
And we just came to the close of our hour. So I want to thank everybody that joined us tonight. Thank you very much. We love your loyal audience that kind of watches us every week. Thank you very much. The team that puts this together, you guys are great. Get some extra sleep. Alex, we want you back and rosy this weekend for the activities. And we'll see everybody in 2 weeks. And so during November, we're going to kind of just do another part of the sky, the greatest story there is, the one about sort of Andromeda and the sacrifice and that going on in the night sky. We'll also be welcoming back Venus, and I'll show you what to look for, because it's about to sort of hit the evening sky, and it's a beautiful, bright object. And I'll tell you why it's not there now and why it will be in about 2 or 3 weeks. And we'll entertain those things this month too. So have a great time. Watch that lunar eclipse, and we'll see you in 2 weeks. Thank you, everybody.